The Computer-Human Adaptive Interaction Group at the University of Sydney, Australia, aims to create new technologies for personalised, pervasive interaction. A key research direction has been exploring new interactive surfaces, such as tabletops. In this video, we demonstrate a software platform called Cruiser, which provides an efficient and extensible framework for developing surface computing applications across a variety of hardware and operating systems. This framework has been used as the basis for a number of research and commercial projects, using a range of devices such as the Xbox Kinect for gestural input. To begin with, we will demonstrate some of the basic interaction primitives with the Cruiser framework. Touching the corner of an image initiates a combined rotate and resize gesture, which we call row size. It enables the user to both rotate and resize the image from only a single point of contact, which enables the gesture to work consistently even on single-touch hardware. An image can also be flipped over, which reveals its file name on the back, and this can also be used to create groupings between objects. Another key primitive is the black hole, which acts as a trash can for the tabletop. This ensures that users can manage clutter while working on the shared display with many artifacts. Objects can be placed or thrown into the black hole, and the object gradually reduces in size as it gets closer to the center of the hole. The hole can also be moved around the tabletop and placed over objects to delete them. The objects can be retrieved by flipping the black hole over to reveal the images ordered on a stack. Holding down on the black hole also creates a vortex that sucks the objects in. Cruiser can display a range of content, including images, videos, text documents, and web content. Cruiser can also display other computer screens. Here we show an interactive object running a conventional web browser with Bing Maps. Flipping the object over switches it to interactive mode, where the user can control the mouse cursor with their finger. Now we see the user using graphics editing software on their desktop computer to draw a picture. The application menu, shown on the left, allows the user to introduce additional tools while in the current application. Here the user introduces a copier tool, which can be used to make copies of any object on the tabletop, which may be important if several collaborators need a copy of a resource in front of them. The copier can also be used with the interactive objects, enabling multiple people to interact with the same computer screen. Here you can see the user copying the big map and placing a copy in front of two other users. Another tool is the storage bin, which acts as a folder for grouping items on the tabletop. The user can place as many items as they like in the storage bin, and the thumbnails resize to fit. The capture frame can be used to take a capture of whatever is underneath it. It can be used on any object, including the interactive object, as you see here. The capture is linked to the original object. An important goal of our work has been operating system and hardware independence, so we can run Cruiser on different platforms. These can range from low-cost tabletop services based on whiteboard capture technology and wall displays that use the Xbox Kinect camera to provide gestural input. We have also been exploring using handheld devices as a personal display while working at a tabletop with a group. Here you can see the same software running on a Windows 7 Slate device, and the user can easily flick information to the main tabletop display. Objects on the tabletop can also be flicked to a wall display using the Xbox Kinect camera for controlling objects on the wall. To control the wall, the user waves their hand and can then control the objects in the same way as the tabletop. Here, the user is controlling a live object showing being mapped, which is synchronized across all the devices in the room. Alternatively, flicking to the opposite edge of the tabletop sends images to a mirror, which is also used as a photo frame. CHI has also been investigating the core functionality required for real-world use of tabletops and interactive surfaces. The first of these is the facility to switch between applications and to alter their configuration. In the video, you can see a user bringing up the application menu and using it to switch to another application. They can alter the files that are being used by the application. They can change configuration options, and they can also introduce additional tools while the application is already running. Here you can see the user switching to an application called Curator, which makes it easy for a non-technical designer to put together a set of media for browsing at the tabletop. The current file collection is about the history of the City of Sydney. While the application is running, the user can bring up the application menu and switch to a different set of files. Here is an educational example, browsing information about different parts of the human body. Another core function of a tabletop is to support people accessing their file collections at the table for collaboration. We now show the Focus application, which supports users walking up to a tabletop to access files stored on their other devices, such as desktop and laptop computers. They can use their smartphones to control which information is accessible by the tabletop. An associative search mechanism at the tabletop enables the users to easily find information based on content rather than the hierarchical organization structure or which device it is located on. Holding down on a file creates a new associative search to find items that are similar to that file or topic based on the document content and metadata. When dragging a file into the middle of the tabletop and holding down on it, it finds items that are similar to that file across all the user's devices, regardless of where they are stored. The results are shown in the middle of the tabletop to facilitate the users discussing them. The users can also control the number of results displayed. The users can also run the Focused Inspector application on their smartphone. This provides a private display for accessing files on the user's devices, and they can control which information is accessible by the tabletop. The user can check files on the device and also send specific information to the tabletop to show others. Once on the tabletop, the user can hold down on that file to locate all other information about that document from any of the user's devices. An ongoing research area is the application of user modeling to personalize the content and the behavior of a tabletop, located in a public space such as a museum exhibit. The user's mobile device holds the user's model, so they can move between different tabletops. The user can walk up to the tabletop and send their persona to the tabletop from their phone. When the user holds down on their persona, the tabletop retrieves the collections of information that would be of interest to them. The information is retrieved by performing an associative search across multiple devices, such as a server in the museum. Here you can see Alice and Bob looking at the materials return after holding down on Alice's persona. Now, Bob sends his persona to the tabletop, and they look at the items that he is most interested in. The persona could also indicate personal settings such as gesture preferences and details for accessing external services such as an online image service. We now demonstrate a range of real-world applications that have been developed using the Cruiser framework. This is a real estate application used in a sales environment for a large land release in Australia's capital, Canberra. enables a salesperson to assist a potential customer in browsing over 400 blocks of land. Any number of the block plans can be opened and compared side by side, and the salesperson can quickly close several items at once to return to a default state. A photo browser can also be used to load aerial photos of the release area. The next application is a tool to support agile software development teams in the form of a story wall. Software issues are represented as post-it notes on the wall, and users brainstorm and lodge tickets using wireless keyboards. Then, they use hand gestures to control the objects on the screen, to assign them to team members and into categories. The interface is designed as an always-on ambient display for a software team. The Cruiser framework has also been used for several museum applications, currently being studied in the Australian Museum in Sydney. The first is an application where visitors can bring in photographs or videos of specimens, such as this spider. The visitor can then send it to a tabletop in the Search and Discover room, where a staff member can give more information about the animal. Here you see a tagging mechanism so that the visitor's image is stored for later inquiries. Using the tag search object, the user can drop images or tags into the top part of the object to see similar items in the row below it. Additional information can also be captured off the museum's website using a web browser. Next is a kiosk application for allowing visitors to gain an overview of the current exhibits and to plan a personalised tour which is downloaded to their smartphone. The Tour Planner object allows the user to drag exhibits into it for indicating things that the visitor wants to see or perhaps wants to exclude. Finally, a personalised tour is generated, which can be downloaded to the user's smartphone by scanning a QR code and loading a web page.